functions again. So a couple of things in general, rational functions. I won't use grades to see them. Rational functions are functions with fractions in them, and absolute value functions. Two different styles of functions. Yeah, rational functions will always have, so if I were to draw a sketch, they'll always look something like, perhaps like that. Two different curves, and they'll be, the reason for this shape is they're separated by numbers that the answers can't be. So there's input and there's output. Inputs are X, outputs are Y, but sometimes X inputs don't allow an answer out. And we looked at that on Friday because if we're left with something divided by 0, it's a problem because it's undefined mathematically. There is no answer. So if we look at a function such as y is equal to 3x minus 2, if this 3 is, x can be a load of values. The only value this cannot be is 2. Because 2 take away 2 gives 0 at the bottom of this fraction, and something divided by 0 is undefined. So x cannot be 2 for this particular function. Cannot be 2. That is called an asymptote. And something that won't go into function. And this would be a dotted line on a graph. Dotted line. Now, when we're saying an asymptote, we don't write not equal to, we just say equal to 2. Because it's this line, well, it's not on this graph because this is a sketch of a different one. This line that goes down that it'll never cross, and it creates this shape. Because as we looked at on Friday, as it approaches it heads towards negative, really large number, and as it approaches from the other side, it goes positive, really large number. But it also will have a y place. What's a laptop for, Sam? It'll also have a y place that it won't cross. And we showed this on Friday as well. If you want to watch Friday's video again, it's online, I think. And we need to figure out, for this one, it's x equal to 2. We need to find out some value y cannot be. What value y cannot be? Well, for most of these and all of these, so the first two, y cannot be 0. Because what happens is all of this multiplies by 0, by cross multiply. So you end up, you're solving for y. So you end up with this situation by multiplying over here. If this is 0, you're multiplying all this by 0, and it's just 0 equal to 3. And that doesn't make any sense. So that shows me there's something wrong with the y output. 0 can never equal 3. So this has an asymptote, y equal to 0. So this is the standard asymptote for a rational function. The standard place. It won't go much beyond that. And luckily for you, you'll never have to calculate this because you can always just put it into your calculator. And you can just see where's the y barrier here. And if it's just the x-axis, it's y equal to 0. Just use your calculator to find these. You don't need to find them algebraically. You won't be asked that. So that's the second asymptote. There's 2. Most of these will have 2. Some of them will actually have 3. And on the last one, C, that's part A done from the homework. The last one, C, had a slightly different equation. Y is equal to 1 over x minus 3 plus 1. And you should have been able to draw this on your calculator. If you drew it on your calculator, you get another shape like this. You will see where this line is. For that line, you write x equal to something. Yeah.
Is that on the x?
These are the two asymptotes, yes. Now, this is a bad sketch because x equal to 2 will not sit there. That's x equal to -2. And that's y is equal to 0. So, maybe now get out your calculator and we'll do this together. Calculator, make sure we can do this. I'll do it online. Go to y equals on your calculator. I'll clear off what I have. So you have y equals. And we're going to try and put in this function. I would suggest putting it in brackets. Start with a bracket. 1 divided by and bracket it again. If you're online, you can follow me. If you're not online and you're trying to put this in, I would suggest putting it in. So your y equals is already there. I would go bracket 1, bracket. Now, what I'm going to put, divided. Divided, bracket, so that's your division, just your division sign. And then put in x minus 3. So the x button, minus 3. And the second bracket to close it. X minus 3, bracket, bracket. And then add 1. So that's how you type that equation. So it's just making sure everything is divided by. So it should look like that. Okay, press graph. This is what I got on mine. Now I can change. You can always change your window. So press the window button. Burgundy, you don't have your calculator today. You can't find it? You're going to have to get a new one because you need it for the exam. We've already provided you one, so you have to get a new one yourself.
Yeah, but my promise to me that I need to find it, so.
Okay. Well, you won't have it for exam. I'm going to usually change your window, so press window button. Change the window from, I usually have it at -10 for the x min, +10 for the x max, the x scale at 1, -10 for the y minimum, and positive. This is just in general, just to see what the graph looks like. So I've changed my windows. This is for the people online. It looks something like that. Now, where hopefully you're look at the people with the calculators are looking at that. For those not, bit of a sketch of it. Kind of looks like this. It's kind of hard to see. Hard to see. Now, where is the x asymptote? Where is the line? It's somewhere here. So you should be able to find that just by looking at the graph. It can be a whole number. What is the whole number from people looking on the calculator?
3.
Is that 3? Yeah. This goes through 3 here. So x equal to 3 is the asymptote, which we should see here because 3 minus 3 is going to give us a division of 0. What is the y asymptote? What is this line? Now, it's not on the x-axis anymore. So that's the x asymptote. The y asymptote, where it doesn't cross, where is this line? Very few people have calculators. That's wonderful. That 1, yeah. So the normal one is at 0, but when I add 1 to the end, it's at 1. And that's not a coincidence. If I add a number to the end, this one is at 1. So hopefully you can see that online. Maybe you can see it on my calculator here. It's at x equal to 3, which is there-ish, that line there, and it's just above 1. Now you can zoom in and zoom out to see that more clearly. So all you have to be able to do here is read your calculator. Please, do you have a calculator at home? Burgundy, you know where your calculator is? Connor, calculator? Francina, you have your calculator? Oh, you have it there? You have to take one? Yeah. Alicia? How do you get the graph in the calculator? Press the graph button. So you can watch the recording of this and then follow. I was showing it up the screen. It's going to be, hard for me to explain how calculator works. Yeah.
Is there a graphic in calculator for its specific one?
Oh, if you're thinking of buying a different one, let me know beforehand because I have to check if it's okay with the design. Okay. All right. Everybody else have their calculator? You don't have that. In general, you have one at home. Yes. It's also in storage, is it?
Yeah, it's supposed to be a message from an ask if you get it on storage.
Okay. You need that. Jaden, where's your calculator? Yes, you need it.
But
Yeah.
it's my room.
Good. It's not in storage.
Fantastic.
Okay, so that's rational functions. Now, absolute value functions from the homework. To solve them, should be pretty straightforward. We did a couple of these. I'll just do one. I'll do part. Is there any particular part that was causing problems? No. Okay, I'll just quickly do part F. It was 2 minus x is equal to 5. What was my strategy here? Anyone remember? Yeah.
So we're looking on,
Yeah. What?
when we get the answer for the first equation, turn the 2 into the negative.
Not quite, Gabe.
There's two answers. One would be the negative x. Other would be the positive.
Yes. Is there a method we can do to do that?
So
Solve it normally? Okay. Yeah, I was showing there's 2 methods you can do it. You can solve it normally and then at the end do the positive and negative x. Yep, that's one way. The other way is to do it equal to the positive and negative answer. Do 2 solutions, one to the positive, one to the negative. Sam?
Does that mean x equals plus minus?
X is equal, x can be 5, or this can equal 5, or this can equal negative 5. We're not sure, because these absolute value brackets turns everything positive, and we're not sure what it would be on the inside. So that's what we're trying to, so this is my method, do 2 quick equations. You can also do it the other way. So solve this, subtract 2 from both sides here, you get minus 7, and x is equal to positive 7 here. Minus x is then equal to subtract 2 from this one, you get 3, and x is equal to negative 3. Now, I hope, Gabe, when you did it, you didn't just go work it out for 1 and then change the sign here.
no, I have 2 answers.
You do, but are they the same answer, plus and minus? No, okay.
One is 7 and one is 6.
Okay, you did it early. Okay, just don't do it at the end. I think this method is probably clearer. Just let it equal to both answers and just work it out twice. That's the way I would do it. So it's just solving algebra. But yes, you've got to do it twice because absolute value turns the answer automatically positive and you're not sure is it positive or negative. And by the fact the graph then goes through 5 actually twice. All right, and then the graph we'll look at now when I put up those answers earlier on the screen, but let's have a look at what the graph would look like, the function. So once again, we'll do this on the calculator. Which one did anyone cause difficulty? Matthew, which one particularly caused you difficulty when you did all these? Wait, do you remember which one caused you in particular difficulty when you hurriedly just threw them on the page? No? No, I didn't think so.
Sir,
Yeah.
I have one.
So I couldn't complete my homework because I didn't have my calculator, so I couldn't sketch the graph.
One of them answers.
I'm going to do this one. Keisha? Positive and negative 5. Absolute value brackets automatically turn an answer positive. So the answer could have been negative 5, but it's been turned positive. Is one way of looking at it. Absolute value is either plus or minus. It always makes it plus. Yes?
Is this still absolute value or it's?
Yeah. So this is absolute value. We're looking at sketching this. So this had a fraction in it. So I'll get rid of this and we look at absolute value sketch and how we put it into the calculator first of all, which those guys who don't have a calculator, this you can watch back later. So I cleared the previous graph, so I just went into y equals top and cleared it over here. Now I need to go and find my absolute value brackets to plot this one. How I find that is I go into math, press the math button, go over to number, so move one over to number. And then the very first one, number 1, is ABS, absolute value. And just press enter on that, it should pop up where you want it to. So you've got a flashing absolute value brackets. Now just put in 2 minus 3x, so we do this. Press 2, press minus, press 3, and X button is up here beside alpha. Now you can press graph, wait a second, and it should pop up as a V shape. Now, it's important that we do draw and sketch it and walking around. Some people had sketched it, but didn't put in, you need to put in some information. So X and Y intercepts are pretty good. So this one comes down like this and kind of bounces off the pad. It's got that shape because it can never be negative. All the negative answers have turned positive. Yes, Sam.
The question is, and then in brackets X, what does that mean? Fx.
That's a function, a functioning.
Number top is only.
It's the same as Y. Same meaning as Y. It's just that the word we're using function instead of Y. Yeah.
When is the test for this? In 1 month.
It's going to be about 3 weeks. Okay. All right. So, what is this point here? Can anyone read it off their graph? You're going to have to zoom in a bit. Is it 1? I think it's just between 1 and 2. Yeah, you got to go in, and there's a couple of ways you can do this. You can actually, if you want to figure this out, if you press second calc, and you press 0, the second one, second calc 0, so second function calc, which is the trace button, and then press 2, 0. 0 is asking where it crosses the x-axis. Press enter. Now it doesn't do anything. It says left bound. You just press enter. Right bound, you can move. So you're trying to move. It comes up as like a star. So left bound, put the star, press enter. Right bound, put the star somewhere over here. And it says, in between these 2 points, where does it cross the x-axis? So those without a calculator, you cannot do this. So I've moved the second over there. I pressed enter. It says to guess. Just press enter. You don't need to guess. And it gives 0.666666666. So this is 2/3. I found it on my calculator. This is 2/3 exactly. Valentina? Press second. So calc. When that comes up on your, go to number 2, 0. Press number, and then it should have these things. It'll say left bound. Just press enter. Right bound. Put it beyond the point, and and then press enter. It'll ask you to guess. Don't worry about that. Just press enter. This gives you x is equal to 2/3. You could try and read it off the graph. It's a bit difficult. Do you think that 2/3 is any relation to this function?
Yes.
Can you explain what it might be?
Well,
2 and 3 are there. It has a direct relation. 2 minus 3x. If you solve that equal to 0, you will get 2/3 because that's where y is 0. That's where the output is 0. So if you let the output be 0, you get it. All right. Minus 3x is equal to minus 2. If you subtract 2 from both sides, divide by minus 3, and you end up with 2/3. And that's, you can get it algebraically as well, but you just have to read it off your calculator. So no issue. Algebraically, no, but you have to be able to read it off the calculator. It's a good way of checking your answer.
I don't understand why it's becoming positive.
If you divide both sides by negative, it's a negative divided by negative, and that's a plus. All right, so that was the homework. The answers I've already put on the screen, so hopefully you've corrected those, and most people didn't do them, so because they were off sick or whatever. Yeah, that'll show up in the exam. But today we're looking at inverse functions. So let's look at inverse. Okay, so we've looked at functions in general. Hopefully this terminology is not new to you when I start writing it up. We have a domain. They are the x values, also called inputs. Put them into a function, which we don't call y equals anymore. We try to use fx. And you get outputs, which is called the range. They're the y values. They're outputs. That's in general what just happens. Now with functions, when we draw them, we get all the inputs, all the outputs, and put them on a graph. See what that looks like. And that's why we get this continuous graph, because their decimal values will get out an output. We just have them all, and they create some interesting shapes sometimes, such as the rational function that we're looking at. Inverse functions is, well, can I undo and work backwards? If I have the output, can I get the input again? Is there a function that gives me the inputs? And its symbol is f little minus 1 and x. It's the reverse or inverse. Undoing the function. What is the opposite function to the function? Simple example. If the function is x plus 3, so we sub in values and we sub in 2, you get 5. You sub in 4, you get 7. What would be the inverse of that function? X minus 3. You work backwards, 7 will give you back to 4, and so on. Both functions are in terms of x. That's one interesting thing, even though, because these outputs start to become the inputs, and we look at that in a second. Right, so we're going to try and figure out how we always get the inverse function, the opposite way around. And it's an algebra skill that you've already done. So let's look at these. Don't need that anymore. Let's look at f of x is equal to 8 minus 3x, and I want to get the inverse of that, the opposite value. Now look at this. When we input into x, into this function, we are going to multiply by minus 3 and like add 8 to it. That's what we're doing to each input. I want to undo that, do the opposite. How do I do it? Okay. First step, I've written it with y, write it with y. Not with fx. Second step, swap. Everywhere there's an x, write a y. Everywhere there's a y, write an x. X equals 8 minus 3y. That's step 2. Step 3, solve for y, or rearrange the equation so y equals again. So this is like algebra when we did, there's a couple of questions in the test on this. Solve this for y. So you should be able to do this. So let's look at it. I'll rewrite it again. You don't have to rewrite it, but so I want y equals. What would my first step be? I want this 8 gone. I subtract 8 from both sides. So I've got x take away 8 is equal to minus 3y. How do I get rid of a minus 3 times y, Valentina? Divide by minus 3. So minus 3 divides into minus 3 once. That's why you need this skill from the previous unit. What am I left with? X minus 8 divided by minus 3 is equal to y. That is the inverse function. Think about what you were doing. You were adding 8 and multiplying by minus 3. What's the opposite of doing that? Dividing by minus 3 and subtracting 8. It's just the opposite operation. How do I write my answer? Write the answer with f minus 1 in it. The question had an fx in it. The inverse will be written f minus 1. So the f minus 1 function, instead of y, is x take away 8 and divide by minus. So it's the same thing, I just written it with the correct notation. So it's a 4-step process. You don't need to write the steps, obviously, each time. You will need to do some sort of solving. So let's do a second example before you guys do some. So the second example is fx is equal to 10 divided by x plus 1. Right? So this time, it's the x thing was 10 over. It's not quite as easy to think of the reverse. Maybe you're thinking you might end up dividing by 10 or something and subtracting 1 in some way. My first step, I'm going to write it with a y. Y is equal to, yeah, no, not really. You can get straight to the second step. You want to just swap it, x and y straight away. Second step, I'm going to swap the x's and y's positions. X equal to 10, y plus 1. So x and y just swap position. And now we have to solve that for y. I want to get y equals now. This is from the algebra unit. What would I do? Chip.
But x with y.
Yes. Multiply both sides by y plus 1. So remove the y plus 1 dividers. X needs to be multiplied by both these. I get xy plus x is equal to 10. I need to isolate y. So maybe subtract x from both sides. Don't want this x here. So I get xy is equal to 10 take away x. And now I need to divide by x to finish. So I want y equals. This should be obvious to you if you knew your skills from the last unit. 10 take away x. That is not the final answer. I need to write it as f minus 1 x. 10 minus x divided by x. Just rewrite the same thing with f minus 1 in it. Okay. Time for you guys to do some. I'll put up a selection. Yes, okay. Yeah. All right. So get going. This is question 1. I'll put it on manage back as well. So just do the smaller. To get going, start on these. See many. Pick whichever ones you want to do. If you want easier ones, do the ones at the start. I'm just going to put this up on manage back now, so I'm going to stop recording and do this on